Hello and welcome to the section 5.1 lecture today for Algebra 1 Part 2. Today our goal is to find slope, finding slope of a line. And the main concept is how steep is the line. That's the main idea behind slope. Okay, but this is going to get us into our unit on graphing lines and then followed typically by writing equations of lines. So that's what we're going to be working on today. Hopefully this will be a little quicker video. Hopefully it's something that we've seen before, but the main thing we're going to be using is this idea of the algebraic equation for slope. So the main idea of slope is that the slope of a line m, and I don't know why we use the letter m, something from older languages for the most part, of a non-vertical line is the ratio of the vertical change, the rise, to the horizontal change, the run. That's why we've probably always heard slope is rise over run. Okay, when we're looking at a graph, we're going to look at the overall change between 2 points on the graph, the vertical change and the horizontal change, and we're going to look at that as a fraction. If we're given points, like coordinates of the points, we're going to look at y2 minus y1, which shows us that rise. Okay, it takes the y coordinate from one of them and the y coordinate from the other point and finds the difference there, finds how much that changes. Okay, and then the same thing with the run. We're going to look at how far the x changes between those 2 points. So how to find the slope of a line. If we're given a graph, we're going to find 2 points. That's what we want to do, is we want to find 2 points. And I get really picky when it comes to where lines actually cross. So trying to be a little bit picky with that. I would say that this is a good intersection right here. And you might be able to argue that this one is right here, but I'm going to push us to find a better one. Okay, because I look at that one and I would say that at this intersection, the line's kind of missing that grid point kind of up and to the left. So I'm actually looking for a better one than that. And I would say this one right here is a good one. Now, if it works out that this slope is a value that would make that one work, then I could, obviously go back and say, well, I guess that one did work. But I don't know if it does. So let's do some calculations here, some just visual calculations. When I'm finding slope, I find my 2 points. That's kind of step one, find my 2 points. I'm going to start it always at the left point and count up or down. Okay. On this one, I have to count up. So I'm counting up until I get to this level. So I always think of this as like I'm doing a little bit of work like I work in a big office building and I have to get to a meeting that's in somebody else's office. Okay, so I think about how many floors do I have to go up or down to get to their level. And then I'm walking down the hallway and I'm passing by all these doors. So I always think of floors and doors. So to get there, I'm leaving my office here and I'm going up 1, 2, 3, 4, 5 floors. And to get to their door, I go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I'm seeing that as I'm going up 5 and over 9. So I'm going up 5 floors. It's the 9th door down that hallway. Okay, so that gives me a slope of 5 over 9. That's not the same as if we would have included this point. It would have been just a slope of up 1 and over 2. Okay, this one ends up being a little bit different. So that's why I get really picky when it comes to finding the right points to use. On the next one here, I think we have a lot of options to choose from. Maybe I pick this one, and maybe for some reason I don't believe some of these in the middle. Maybe the next one I really see is that one right there. It turns out that it's not going to matter on this one, but I still think of it the same way. So I start at the left point. This is me in my office building, in my cubicle or whatever, or even standing at the elevator. And I need to go down 1, 2, 3, 4 floors to get on their level. And then from their level, I'm going over 1, 2, 3, 4 doors. So I'm going down 4 floors, and it's the 4th door on the right is always what I think about. Okay, so that gives me my slope, though. I take my rise, -4, over my run of 4. And when I simplify that fraction, -4 divided by 4 is just -1. So there we go. We're done, and that's all. And that means that it would have worked out to pick this one right here to go down 1 floor and over 1 door. Okay. And really anything in between, you could have picked any of those values. But as you get more and more experience with this, you will notice that the, oops, I didn't really want to do that, I guess. You will notice that the coordinate method would work out too, right? This coordinate here is at -4, -1. And this one here is at 5, 4. That's kind of tough to see because I've written over the axes a little bit, but that's where those 2 points live. And if you were to do it using the equation, you would get the same thing. Pick a y2 and a y1. Let's say we go 4 minus -1, and then we have 5 minus -4. 4 minus -1 turns into 4 plus 1, and we get 5. 5 minus -4 turns into 5 plus 4, and we get 9. We get the same thing. And that's why both strategies work. I'm a big fan of the counting, the floors and doors kind of mentality, but sometimes you need the other one too. Let's look at some different varieties of slope that we might get. And this is a good strategy to kind of rule out some possibilities based on what a graph looks like. A line with positive slope rises from left to right. That means that the m value, the slope, is bigger than 0. And that's this one here. So from left to right, it's going up. Okay, and I always think of this. So I've got the floors and doors idea. I've also got the positive, negative, 0 idea. And I think about standing over here. And I think about this being my treadmill. Okay, I'm having to put in effort to walk up that line. That treadmill is a pretty steep incline. So I'm having to put positive energy into it. When I'm standing on this one is a negative slope. And if this was my treadmill and I'm going this way, I'm having to put less effort in, less energy in, because gravity is helping me out. On this one, this is kind of my neutral, right? This is my flat treadmill, and that's a 0 slope. I don't have to put any extra energy into walking on that treadmill because it's flat. And then this one, I just kind of think, what do you want me to do? Right, that vertical one. When I can't think about putting myself on that treadmill, that's my undefined slope. Okay, and that happens on vertical lines. All right, let's go ahead and look at these couple other examples. So here we are using our slope formula. That's always going to be y2 minus y1 over x2 minus x1. Okay. So the first thing I always do when I come across a problem like this is I'm going to label x1, y1, x2, y2, and then I can just plug those numbers into this formula and figure out my slope. y2 is 3, y1 is 5, x2 is 2, x1 is 4. So I didn't think about that. I went with my formula and what I had labeled what, and put the numbers in where they go. On this one, we get 3 minus 5, which is -2, and 2 minus 4, which is -2, and -2 divided by -2 is +1. So I get a slope of 1. Okay, let's look at that same thing on this one. x1, y1. I'm going to put these down below. x2, y2. And know that my formula always starts with y's on top, and it always starts with the 2's. Y's on top, x is on the bottom. 2 minus 5, and 5 minus 1. I know this seems like a tedious process, but I do it every time. And if you think it's tedious for you, imagine how I feel. Next one here we have 2 minus 5, which is -3, and 5 minus 1, which is 4. And there we go, we're done. Okay, last one over here, do the same thing. x1, y1, x2, y2. y2 minus y1 is 0 minus 3. x2 minus x1 is -3 minus 2. 0 minus 3 is -3. -3 minus 2 is -5. Negatives cancel out, and we get 3/5. Okay, go ahead and pause the video and give these last 3 problems a shot. Okay, hopefully you had a chance to do that and you actually did it. And if you want bonus points, you'll show the x2 or the x1, y1, x2, y2. I just think it's a good strategy to keep you focused on what you want to do. y2 minus y1 is 0 minus 6, and x2 minus x1 is 8 minus 0. We get -6 over +8. That actually reduces to -3/4. You should be reducing your slope whenever you can. Next one here. x1, y1, x2, y2. y2 is -4. I guess I need my m equals. -4 minus 4 over 4 minus 2. -4 minus 4 is -8. 4 minus 2 is 2. That's going to simplify down to be -4. And last but not least, x1, y1, x2, y2. y2 minus y1 is going to be 4 minus -1. Oops. -1, not -4. 4 minus -1 over -6 minus -6. We've got some minus a negative issues to deal with. That turns into 4 plus 1, which is 5. On the bottom, we end up with 0. Okay, we cannot go 5 divided by 0. That means this is an undefined slope. Okay, undefined slope. Because it's a vertical line. If you think about it, -6, if I've got my axis here, -6, -1 would be somewhere about here, and -6, +4 would be somewhere about here. Okay, you have to envision these lines continuing, but we get that vertical line right there, so that's undefined. All right, hopefully that helps out a little bit. Make sure you put any questions you have over on the left and watch this before your first class this week. Otherwise, have a great day, and we'll see you in class.